there is a three dot, and if you click, there is a more and a record and transcribe. So there is some recording options there.
Okay. Hopefully it's recording my PowerPoint screen. Alright, this is just design of storm drain and using Envoys.
Yeah, Ankur knows how to record it. Ankur, can you record the presentation?
I have it being recorded.
Yeah, David's doing it.
Okay.
Yeah, it looks like it is being recorded.
Okay.
Alright. So welcome to the storm drain design using Envoys. This will basically be a back and forth between the PowerPoint and CAD examples of how to start Envoy design for storm drain. So first off, we are going to okay, the first slide. The first thing you have to do before you get started is to make sure that you have the following existing DTMs, surfaces, and modes of the photography file for like a baseline. Usually highway has an alignment file for you ready to go for the roadway. And you have a proposed DTM file and a drainage area map with complicated runoff factors. And by that, I mean we use the rational methods as we covered in the first part for the storm drain systems. Okay, so the first thing you need to do is step one. You need some. I'm gonna go through all this as an example guide. This is just a reference for you guys to look at when you guys are doing your own storm drain network. So share my screen. So we want to start this off with we already have an MDD file, and see I have my alignments and my post detail and my existing detail. And I usually have my MDD, two separate MDD files for those. This is MDD for the plan set for plan. This is MD for design. So I drag this over and open it in my Power Invoice. It's opening up now. Mm. So this is my enrolled file. I'm trying to see. Mm. Okay, there we go. That's fine. So this is my enrolled file here. So here's my layout, and I can see have no design systems in here. So the first thing you want to do is, make sure our settings are correct here. Wait, it's not showing. Okay, can you guys see that now? Okay.
Yep.
Oh, okay. So the first thing you want to do is go to file, make sure new, and Google drainage database, Monterey Avenue. And you say proposed drainage. And you click apply. And now when you the different tabs here, to surface geometry. Now you have drainage. Your project will show up in here. Okay. So that's how you create a new project file. You want to save and then save as, save drainage data. You save in your project folder that you have. Training. It will be called an FTP file. And you save it. And it'll show up. Okay. So that's how you start. Now the next thing you want to do step 2 is laying out storm drain system. But first, I want to expand more on the step 1 settings as well. So the first thing you have to do for this is to make sure I hope it's being recorded when I share it both screens. So you want to go to project layout, project defaults. You want to make sure you have the right default and functions in here. So if you have like none, you can create a new one. Instead of, mine. It's okay. And then you want to create the buffer, your data structure, and your rainfall data. So your preference, you can click on browse. And then you go to your SUI and your CAD standards, VAI, and you have invoice. And you have SSA VAI, which is the most usual one, Civil. And you open that up. And then the data structure, which will allow to have the data to apply and when you set up your layout. So browse, go to the same invoice folder, Stormbridge, Gentile, and you have the structured data here. You open that. Now your IDF, which is your rainfall data, so which account for your hydrology and rainfall. In order to do the flows, so this is in the same category, storm drain sewer, and you have different counties for IDF curves. Now, Monte Island is located in Baltimore, no, I mean Anne Arundel County. Now you click on Anne Arundel County IDF curve, you open that up, and then you click apply. So now you go back to your default. Make sure you go click on there and then you apply it. And then you just save it. Now, if you save it, it should automatically have 1, 5, 3, 4, 30. That. Okay, so now we got that set up. Now what we'll do is do our layout, okay? So what I want to do is I want to input my MDD I have for my training. Which is my layout I already have set, just so I can know like what base point. So usually we already have a layout section and everything. So for this part, I'm going to start from I3 all the way to it's just a middle one to middle one. So the first thing I can do is do shut window. So this is just going to talk about what I'm doing next for you guys. So I'm just going to go to the guide example and go through it, okay? Let's shut this window. Okay, so layouts, okay? And also the first thing, like I said, in the settings, you want to make sure you have your surface and your alignment file in the settings. Okay, so what you can do is your DTM, you can just drag it over and it will add it to your surfaces already. And then your existing surface, and then your alignment file. Okay. Now, one thing you can do is check and make sure it's the right file. You can evaluate. Go to evaluate. Tracking tool, tracking, activate. Make sure I need to post the proposed grading. I set it active to activate. I want to make sure I have it right elevation. So this is how you check the elevation here. This is 214. This is 213. That's all right. So we know that's right, okay? So that's how you check it. Alright, so alright, so let's start off the layout, okay? So you always want to set your structures first, your inlets and manhole first, so it's easier. It'll be easier for you in the long run. So you go to drainage, layout, you have pipe, piano, culvert, manhole, inlet. So you have this inlet here. And then you're gonna name it I-3. And then you can add it by just clicking on this crossbar, and you'll notice that it'll shoot the elevation, which is going to be your top of structure here. Your top of structure. And then you can choose the inlet that you want. I click on the option, and as you see, it's looking at my data structure. So right now, we're just a curb opening and a curb on grade. I usually now the 6 inches or 8 inches is usually the curb height opening. So it's typically 6 feet usually. And then I just usually do a 4x4 box culvert. And then the opening line is how big your inlet is. Whether it's a 5-foot opening inlet or a 10-foot opening or a 15 or 20. The maximum we have is 20. So, but for this one, it seems like we're using 10 feet, okay? So 10 feet. And then it's on grade. Depression is usually like 1 inch or 2 inches. And then you click apply. And then you close it. And then now we have always that click apply. And it'll show it here. It might be a little bit off a little bit, but you can always move it when you're done. Okay. And then you can do manhole 4, manhole 4, kitchen structures. Then you go option. Use a precast manhole 4 feet. You can just get that in manhole. I usually do a precast manhole. 4 feet wide because the 15-inch pipe here, so it's okay. When I do depth below invert, I usually do like the drop across. I usually do 0.2. Then you click apply. And you click apply. And then it'll show up here. And then now that you have your structures in here, you can set your pipes here too. You want to set your pipe. So usually I name it I-3 to manhole 4. And then you choose your upstream. You click on the upstream structure and the downstream structure. You click on that structure. That's automatically connected, okay? Let your invert in, invert out. So this invert in will probably, it will automatically select the depth for you based on the minimum invert that's needed based on the SSA standard. And you change the invert to whatever you want. You can have this set and then you can change to like 1%. and then you click on options for the pipe. You circle the pipe, and then you can choose a 50-inch pipe here. And then you click apply. And then you can click apply. Okay. Okay, so I'm just gonna go through this really quickly. Start up the system really quickly, and then we can move on from there, okay? So, for go back and apply pipes. So 2 life structure, 15. When it says 2 life structure, usually it means stopping up with the solution and everything. No, man. 2. Now, when you go to the next pipe, it automatically picks up the downstream structure for you at M4. And now you have to do is click on downstream. Okay. And then again, we wanna define our structure first. So I just wanted to show you how to do the structure in the pipe, and then so it's easier if you do all the structures first. So the manhole, 13, on and apply, and then we do M3. M3 apply, and then what's the next M2, then M1. M2. Now we're gonna go to inlet, I1. Have the same. Then we have I2. Well, now I have my top. Now we do the pipe. Now I can go to Emma, manhole 4. And make sure you save your file periodically. Okay, then and 4. Now the name of the pipe is very important, because later on when you do the structure schedule and pipe schedule, it will let you keep track of everything. Manhole 5. Fifteen pipe with apply. And then geometric. Do- Think about so that's the structure. Devices, about yeah. So that's the structure that you have here. And then you just close it, make sure you save it. And data. So that's the layout, okay, for some structure. So let's show you how the layout that. So now what you're going to do is share this window. We went through this before. We did the drainage and everything. Now we're doing a storm flow computation. Okay, so storm flow computation, which I have here. I have the flow drainage. I should have I1, I2, I3. So what we're going to do, now this I3, as you see, I have the flow, I have the drainage area, I have the coefficient and everything. So you go drainage, compute. Okay, use the random method to compute it. So what I'm going to do is I'm going to go back to my folder here. Share this one down. And I'm going to go to drainage, flows, and compute flow. So I like to match my area ID with the inlet that I'm using. So I think this is I3 here. And you can check by like hovering over it. It'll be inlet I3. I like to do I3. In my drainage area, no, based on my I3 is 0.23. My runoff coefficient is for less than 25 years is 0.39. Typically we design it for a 10-year storm. I do 0.39. And my time of concentration was 5. Okay. Now it automatically give you 0.49 CFI. But as you see, that's for the 2-year storm. So we want to do it for the 10-year storm. So the way you do that to change it is you go to option, design, no, area, and change your frequency to a 10-year storm. And you click apply. As you see, you pick out my Anne Arundel County idea. You click apply. Now, let's try it again. And now you should have it in drainage in your area. I1. You can edit it. Just a back to I3. Okay, second rational. Still says 149. Let's ask again. Let me just do option first. 10-year, then apply. Okay. Okay. Let's try I3. Okay, now it's working. 0.63. And then you wanna, I guess you can, then you wanna attach it to the index that you want. Attach it to I3. Okay. So it won't let you change the area ID, but you can attach it, and then you can click apply. And now when you go to the area, you can attach the I3 rational method intensity based on 10-year storm and the peak flow time of calculation. So you just do that for all your inlets. Okay. We only have 4 inlets. I4 manage area for I4 1.1.35 and 22 minutes. Yeah, 1.1.35 and 22 minutes. And then you attach it to I4. Then you click apply. I1, I2. Go to I1, 144. For 5 minutes, 1.2, and then you attach it. I1. Then you apply, and then the last one, I2. 1.13, 15 minutes. 15 minutes. And then we have 0.32. Then you apply. So now all your fields are signed here. I have all your fields assigned. You want to close it, and then do drainage. network, design the network. Now you have the structure here. Let me shut this window. You can click on that. I don't need to be computer and invoice your computer stronger and louder and report in the following format and everything. So go back to you shoot. So when you shoot a network, you shoot the one that's the most downstream and you shoot like manhole one. Okay. And then it'll generate your ACL and everything. So for this ACL here, just ACL, we usually use the most downstream pipe invert, and whatever the invert is, we use the top of pipe. So when I go to the pipe, I know it's manhole 2, manhole 1. I click on edit. Look at my invert out, it's 199.33. And then 50-inch pipe. $200.58. I use the water level at 200.58. And now you just click apply. And everything will come out to your flow and everything. And you can check the capacity of your inlet. The capacity of the pipe here. So you see pipe I3 and manhole 4. The total flow is 463, but the capacity is 6.458. That means everything is okay. So that's how you do that. Check your capacity for the pipes. Close it. I forgot to assign this to my I2. Apply. I'm on my training network again. Now I don't have any errors here. And also you can check the spread of this inlet as well. See it through here. So if you just inlet here, you can check to see the spread. 5.36. Okay. And you can save this text file. Save it as ACL or application would. And save it. Now that's for the network. So there's another way to do it for get your result if you want a simpler version. So we can do it through I think report here to drainage report, and you can choose what kind of report you want. it's actually choose between the pipe inlet. Like for inlet, you should just have like the spread. You can do it between the inlet, design data, physical data, design data. And you click apply. It'll show you like the spread of your inlet here. To summarize. And the same thing for pipes. Pipe, the design data, apply. It'll show you like the total flow and the capacity of the pipe, your velocity, your depth of flow in the pipe, etc. Okay. So that's basically how you design your structures, your network, how to get your reports and everything. Again, this is being recorded.
David, just one thing to add here. Just, like as David's been showing us for the past, since this training started, there's a lot of like manual entries, right? This inroads tool definitely helps and does a lot of the work for us, the calculations and generating profiles, which I think David might get into after this. But the most important thing is, it's only as good as the input data we put in. So all these little manual entries, there's obviously a lot of opportunities to make mistakes. So I just advise, anyone who's doing this kind of work, make sure you take the time, double check as you're typing these numbers in. Anytime you see a summary table, take the time to double check at that time. Because basically once you print it and put it in a report, it's a page of numbers and some profiles. So if mistakes are made, it's hopefully we catch it during QC, but we really rely on the people actually doing this work to input it correctly the first time. If there's a problem with the calculation, drainage area map, that's a different story. But whatever the discharge or drainage area or curve number is in our calculation, that should match inroads from the start. Okay.
Yeah,
Sorry.
right. Yeah. So make sure you double check the numbers and everything, make sure okay, and matches the report. So this stuff I'm gonna get into next here. So I'm semi-clean. Share the window.
Can you hear me?
Yeah, we can hear you, Solomon. You can.
Yeah, I just want to make it clear I understand this correctly about the inverts. You said invert out at the manhole 1. I thought it's gonna be invert in. How is it working? This system? Can you tell me?
The invert in, you said?
Yeah, I thought you're gonna say invert in, but you put invert out for manhole 1, for example. So the invert in and outs how are they defined in these inroads?
Okay, yeah. Okay, fine. I'll go into that now.
Okay, please.
So basically, you want to go to the pipe here, okay? And so this is manifold.
I can't see.
Oh,
Here.
let me show my screen. Okay, can you see that now?
Yeah.
Yeah.
Okay. So we're gonna go get the inverse. Okay. So this is
Manhole 1, right?
manhole 1. The pipe manhole 1 to manhole 2. Inlet 1. Manhole 1. Manhole 1 to manhole. the other invert. So you see the invert here, okay?
You see?
Yeah.
So I thought that invert 199.33 is gonna be invert in because the pipe is coming into that manhole.
Yeah. So the pipe, so this pipe here, the invert in, as you see, is coming from manhole 2 to manhole 1. So invert in is referring to the upstream pipe
Oh.
that's coming out of manhole 2.
So that is in to
Yeah.
manhole 1? Oh,
Correct. Yeah.
okay.
And
Okay,
this,
I see now. Okay.
No,
and the invert out will always refer to the downstream end of the pipe.
yeah, basically for these things, I think, based on if you set up the invert based on the structure will be very confusing.
Yeah.
Basically you set up the invert based on the slope for the pipe. For example, you collect the pipe and you know the invert in out and slope, right? Based on that, the software will automatically set up your structure depth based on your top elevation and the invert pipe, invert in, invert out something.
So
Not try to set up the invert in, invert out based on the structures. That you not easy to. You just like, for example, the first pipe, you click the first pipe, you set up invert in, invert out, and the second pipe invert in, out. The structure invert in, invert out will be automatically set up. Yeah, you see, you say invert in, invert out. You click the pipe invert in, out. Yeah.
Yeah,
The structure itself, yeah. You don't need to set up the invert in, out based on the structure. You invert in, out based on the pipe, yeah.
Yeah,
It'd be more
invert.
easy.
Yeah, so invert does it a little bit tricky. I know it's confusion. Like you think this is, you would think that this would be called invert out, right?
That's what I thought, yeah.
No. So invert does it backwards a little bit.
Okay.
Okay, so this
Okay.
is just invert in.
In. Okay.
Okay.
Good.
So invert in is just talking about the upstream end of the pipe.
Okay. Good. Thank you.
Okay. Alright, so now that we do this, now we're gonna work on the profile here.
Yeah, David, I think one more things we need to mention here is when you put the structure in, you need to put the concrete box exactly the location, not just like put you, for example, here you need to put the right location, not just like put with some kind of angles. Because the structure location will determine your pipe length and slope, whatever, you know what I mean. So you need you need to put the concrete box in on the right location. Now, for example, for the inlet, you put is not the right location, right?
Okay,
Because
yeah, so
because here in the training class, we need more accurate, not just like a.
yeah,
You know what I mean, right?
Yeah, I know what you mean. So like you're talking about this angle here, right? It has to be flat with a curve.
Yeah, that's what Jerry. Aligning the face of the inlet with the curve.
Right. For example, your box. Basically, the box is for the curb inlet or whatever the inlet. This is exactly the box side. So the box, the inside and the outside, right? They have like a 9-inch or 6-inch thickness. So you need to put the box along the in front of a curb. Right, that's the way you can get the right, pipe length. Otherwise, the pipe length is wrong, and your offset is wrong also.
Right. Well, yeah. so you can do a lot of the curve in that. You probably edit it a little bit. But yeah, I know what you mean. So like, you can do drainage layout and like and this we're talking about the angles and stuff, right? So you want to make sure, like, this is the back of curve here, and then the angle you just click on, I think, like this. The option, apply, like that. That was the thing.
Yeah, that's what he told. Let's move on for the training purpose. That's fine.
Okay, yeah. And
Yeah.
that's how you do it by angle. Right now, I'm just trying to show you the location, but that's how you do it by angle. You click on this line and make sure it's along this line here, and then it'll be good to go.
It needs to be on the line and you know, because this is not what's displayed in the plan, right? So whatever is in our MDD, it really needs to match super accurately with that, because otherwise, like Jerry is saying, because the length of this pipe is what's going to be in the pipe schedule and what's going to end up in the cost estimate and what's going to, you know, change the slope of the pipe as well. So that kind of stuff, it really needs to make sure we match, you know, what's in MicroStation in the MDD file. That's an easy thing to make mistakes on for sure. You know, we'll have a few feet short in the construction. There'll be a few feet short of the pipe basically and then we'll get an RFI and then it'll be a headache. So
Yeah, Ankur is right. And also we need to, I know they did a very good job to present this. A couple of fine tunings we need to do when we do a real design. We cannot come through the corner of the inlet. We need to go to the face of the inlet, and also Jerry's and Ankur's concern is good. But this is a training, so that we will do while designing. So for now, it's fine. So they please proceed with the. You told you will do some profile or do.
Yeah, I'm gonna do a quick profile and
Okay.
in Google, okay? Alright, so this is profile. So you got your evaluation profile. I'm gonna create profile. Join layout. So I have my proposed layout here in my existing here. So usually I click on property. Monitor this is my existing, and I choose my surface suggestion and click apply. Mm. Choose property for this one. Make sure it's like it's proposed. It's stuff is proposed. And stuff is proposed. Click apply. So this will define your line type when doing your profile. Surface suggestion. Apply. Okay. Now we do it 5-to-1 slope, 5 vertical gyration of 5-to-1. Now if you go to source, you want to choose it by network, okay? And then the network you want to do farming to. So to farm, you'll go to your upstream area. You click on your upstream area. And then 2, you click on the middle one. And then you make sure you choose network. And then in the controls, you don't need like clearance or anything like that. And then network type outside. You want to display your ACL, which you calculate already. And then you click apply. And then you can start the profile in here. Okay, and that's like your profile. I think I have my override on. There we go. See. And so for certain purposes, you can see, this is my proposed. This is my proposed line. This is my GIFN. As you can see, all my pipes are way above everything. So that means I have to fix my inverse and everything here. So you would think that, I have to go to my layout and fix my inverse, but that's not the case. You can do it really easy in the profile itself, okay? And so how to do that in the profile is you go to tools, joining, structure, and moving profile. And you click on the pipe that you want to move. You can move it down. You can click on this pipe. You can move it down. And then click on the pipe. Now, if you click on the middle, it'll keep that same float. Okay. But if you click on the right side, it'll get the upstream side a little bit. Okay. And then you can just move it. You can keep that same float and just move it down a little bit. Just so you get positive downstream flow here.
Dave, I'm just curious why the first inlet, second inlet shows the incoming pipe is above the ground.
Yeah, right here. So, good question. So this inlet here,
Mhm.
so we only did the profile for I3 coming to this manhole one. We didn't do the profile for this section only. So so that pipe that you see here is influenced by this pipe here. So what I do is I'm gonna show you how to do it. You can create another profile, okay? Create a profile. Choose a different source. Go from I3 to manhole to and click apply. Okay. Now, and then when you move this thing down, so this pipe is showing this pipe here. Okay. So we can just adjust what could be shown here. So we can adjust this thing.
So pulling that pipe down, right?
I can move it down like that, right?
Okay.
And then, so now what you do, you save it. You save it. Drainage area. Okay, net drainage. Run the network again. And now you know that this is not being updated, right? So when you click on this evaluation profile, you update journey profile. You click on the journey profile you want to update. Now, watch what happens You can update alternating profile. Watch what happens to this man over here. You click apply, boom.
Okay.
It'll update it for you.
Yep, that's cool.
You can update HDL as well. Okay. Now this HDL is not being correct because my pipe is already up here now. Tool evaluation. Network director. Moving profile. Now once you move it, you have to rerun the network again. Run the network again, apply it for an HDL. And then my water level might be different now because my pipe info is different here. And so let's go to the pipe. The last one. See what the info is, 197.37. So it's like what 198.5 maybe. Because that's the top of the pipe apply. And now we save it. And then you update alternating profile, or you click apply. Now you see my HDR a little bit better. Okay, this is my HDR line.
Yep, that's good. And can you speak about the tailwater things? What are the options?
Yeah, so what's the option? So when you do the HDL, you wanna always pick your downstream of the pipe. Okay. So, but sometimes your alpha, you might want to choose an alpha. So sometimes you might have like a pipe alpha into like a pond or a big or a river or something. And so you might, so your HCL might start at your 10-year water surface elevation of the pond itself. So that's how you set your tailwater elevation for the alpha into a pond or a river. They might have, the river might have its own mean high water line. 10-year water surface elevation, water surface elevation. That's how I do the profile.
Where do you put
Also,
the tailwater information?
What?
The tailwater elevation, where do you put it?
So you put it, so you, like I said, you put the tailwater or water surface elevation. When you do your network and you click on the design, you shoot it based on the water level here.
Okay, I see. Good.
so
And
hold on. Is there an option to put a rating curve?
A rating curve. I'm not sure about that.
Because we designed the storm drain for 10 year and SGL is for 25 year. 25-year water surface at the tailwater may be way higher than 10 years. So always it is better to seek options for the rating curve if there is an option. So
Yeah. So if you want to do it for 25 years, that's fine.
oh, okay.
So all we have to do is go to our area, right? Go to our flow, compute flow, and then I think go to option and change it for 25 year.
Okay.
And then you click apply.
Mm-hmm.
Okay.
Yep. Thank you.
And then save it. And then you run it again. So you run it again. Okay, now that you ran it, now check and see our update the thing here. It went out a little bit, but let's see. Okay, intensity didn't update. So maybe drainage flows. Maybe I can edit this. There's a way to do it. Maybe Jerry might not have update it automatically for your intensity. Or see. But that's what you can do for 25 years on. You can like maybe make a separate STB file and just name it 25 years. But it's really good. I just want to do a couple of quick things, and then we'll go. I want to show you how to and I'll take the profile and I'll do the pipe and structure schedule. Okay, you give me another 10 to 15 minutes, and bear with me. So,
Hey, David, how about we, because I think we have a third training scheduled as well, I believe. So why don't we,
Okay.
yeah, why don't we wrap, instead of rushing now and we're over the time anyways, let's maybe put a pin in it here and we can pick it up next time.
Yeah, note it where you left them, and we can pick up from there. We can let's wrap up now.
Okay. All right. That's fine. All right. So I'll let you go. All right. Anybody any other question, concern?
Yeah, we are already more than 1 o'clock. So I think any questions, anybody, please direct to Dave. You can give it to me, Ankur, or Dave, so we can answer that in email or we can call. So I think it's more than 1 o'clock. So I really appreciate everybody attending this. Very appreciated, and huge thank you to Dave. Ankur, Salim, you guys have anything?
Oh, I think we're good. Thanks, David.
Yep, thanks, David.
Yeah, thank you. Yeah, thank you, Dave. Thank you, everybody. Have a good day. Bye.
Thank you.
Thank you.
Thanks, David.
Thank you.
All right. Thanks. All right.
Bye.
Thank you.